Hello, everyone. Welcome to today's video. Before we dive into today's content, I want to take a moment to express my gratitude for each and every one of you. Your support means the world to us, and it motivates us to create more valuable content for you. In today's video, we have something really exciting in store for you. We'll be briefly describe about Dockerfile. I'm sure you're going to love it. But before we get started, I'd like to ask you for a small favor. If you find this video informative, entertaining, or helpful in any way, please consider giving it a thumbs up by hitting that like button below. It really helps our channel reach more people and lets us know that you enjoy our content. If you haven't already, don't forget to subscribe to our channel and turn on the notification bell so you never miss an update from us. We have a lot of exciting content planned, and we'd love for you to be a part of our community. Once again, thank you for being here with us today. Your support keeps us going, and we can't wait to share more incredible content with you. Let's jump into today's video. What is Dockerfile? A Dockerfile is a text file used to define a set of instructions for building a Docker container image. Docker containers are lightweight, portable, and can run consistently on various platforms. Here's a detailed explanation of how to write a Dockerfile with examples. Docker files are a fundamental component of Docker, a containerization technology. Docker containers have gained popularity in the software development and IT operations communities due to their numerous advantages. Here's more information on the importance, usage, and advantages of Docker files. 1. Importance of Docker files. Reproducibility. Docker files define exactly how a container image should be built. This ensures that your application's environment is consistent across different stages of development, testing, and deployment. Version control. Docker files can be version controlled using tools like Git, allowing you to track changes and roll back to previous configurations if needed. Collaboration. Docker files make it easy for development teams to collaborate on building and deploying applications. Developers can share Docker files to ensure everyone is using the same environment. Scalability. Docker containers are lightweight and can be quickly deployed and scaled. Docker files are a key part of this process, allowing you to create multiple instances of the same container. Isolation. Containers provide process and file system isolation, allowing you to run multiple applications or services on the same host without conflicts. 2. Usage of Docker files. Application packaging. Docker files are used to package applications, their dependencies, and configurations into a single container image. This image can then be run consistently on different environments. Continuous integration, continuous deployment, CI/CD. Docker files are often integrated into CI/CD pipelines to automate the building and deployment of containerized applications. This ensures that code changes are tested and deployed consistently. Microservices. Docker containers are well suited for microservices architectures. Each microservice can be defined in a separate Docker file, making it easier to manage and scale individual components of an application. Development and testing. Developers can use Docker containers for local development and testing, ensuring that their code works in the same environment as production. 3. Advantages of Docker files. Portability. Docker containers and Docker files can run consistently across different environments, including development laptops, testing servers, and production servers. This portability reduces "it works on my machine" issues. Efficiency. Docker containers are lightweight and share the host OS kernel, making them efficient in terms of resource utilization. You can run multiple containers on the same host without a significant performance overhead. Isolation. Containers provide process and file system isolation, preventing conflicts between applications or services running on the same host. Version control. Docker files can be version controlled, allowing you to track changes and roll back to previous configurations if issues arise. Scalability. Docker makes it easy to scale applications by running multiple instances of the same container image. Security. Containers offer a level of security through isolation. Vulnerabilities in one container are less likely to affect others. A Docker file typically consists of a series of instructions, each of which performs a specific task. Here's a basic structure. Now, let's break down each of these instructions with examples. From specifies the base image. This is the starting point for your Docker image. You can use an official image from Docker Hub or a custom image you've created. Example. From Ubuntu 20.04. env sets environment variables. You can define environment variables to be used within your container. Example. env my_var equals my_value. Run executes commands during the image build. Use run to install software or configure the image. Each run instruction creates a new layer in the image. Example. Run apt-get update and an apt-get install y package name. Expose exposes ports. You can specify which ports your container should listen on. This doesn't publish the ports to the host but serves as documentation. Example. Expose 80. Workdir sets the working directory inside the container. You can specify where commands should be executed by setting the working directory. Example. Workdir app. Copy copies files or directories from the host to the image. Use copy to transfer files from your local system into the image. Example. Copy my_app. Entry point defines the entry point command. The entry point instruction specifies the command that will be executed when the container starts. It's often used for the main application process. Example. Entry point Python app.py. cmd provides default arguments for the entry point. The cmd instruction provides default command line arguments for the entry point instruction. It can be overridden when starting the container. Example. cmd verbose. Putting it all together. Here's an example of a complete Docker file for a simple Python web application. Use the official Python base image. From Python 3.8 Slim. Set environment variables. env my_var equals my_value. Set the working directory. Workdir app. Copy the application files into the image. Copy my_app. Install any necessary dependencies. Run pip install r requirements.txt. Expose port 80. Expose 80. Define the entry point command. Entry point Python app.py. Provide default arguments for the entry point. cmd verbose. To build an image from this Docker file, you can use the docker build command. Docker build myPython app. This command will create a Docker image named myPython app based on the instructions in the Docker file. Remember that Docker files are highly customizable and can be tailored to your specific application's needs. In summary, Docker files are a critical tool in the world of containerization, helping developers and operations teams package, distribute, and run applications consistently across different environments. They play a vital role in enabling efficient development workflows, ensuring reproducibility, and simplifying the deployment of modern, cloud-native applications. Well, that's a wrap for today's video. I hope you enjoyed it as much as I did creating it. If you found this video helpful or entertaining, please don't forget to give it a thumbs up by clicking that like button below. Your support means the world to us. Stay tuned for our next video. Before we go, I want to express my heartfelt gratitude for your continued support. It's because of viewers like you that we're able to do what we love. Thank you for being a part of our family. Well, that's it for today. Until next time, take care, stay awesome, and keep chasing your dreams. I'll see you in the next video. Goodbye.